In this episode of Single Variable Madness, we have the integral from 0 to 1, the definite integral from 0 to 1, of 1 minus x divided by e to the x plus x dx. So trying to solve this just like it is pretty difficult. U substitution may not help that much because there doesn't seem to be a good u that we can substitute in, and then integration by parts may not seem to work. So how else can we do this? Well, when we have a difficult function that we want to integrate, the best thing to do is to rewrite it, usually. So we have 1 minus x, I'm just rewriting it here, divided by e to the x plus x. What can we do in this situation? Well, in this case, this minus x is kind of pesky. We don't really want this here. So how about we add 1 and subtract 1? Now, what I mean by that is, well, if we add 1 and then subtract 1, obviously nothing will happen, right? But what if we write the first add 1, as e to the x plus x divided by e to the x plus x? And then, of course, the minus 1 stays the same. Well, in this case, since these two have the same denominator, we can add the numerators together to get e to the x plus 1. The minus x and the plus x cancel out, and that's all over e to the x plus x. And there's a minus 1. So we have rewritten our function, our original function, as this. And we can just take the integral of this instead, from 0 to 1. The definite integral from 0 to 1 of e to the x plus 1 divided by e to the x plus x minus 1 dx. Well, in this case, it's actually a lot easier to integrate this. Obviously, the minus 1 becomes minus x when you integrate it. But in this case, all we have to do is write it as ln of e to the x plus x. And then again, minus x from this minus 1. And we have to solve this from 1 to 0. Now, first of all, why is this the integral of this fraction right here? Well, that's because if you take the derivative of this, well, in any case, the derivative with respect to, let's just say y, of ln of y, some value y, that's equal to 1 over y times the derivative of whatever's inside the ln function with respect to y. In this case, it's just 1, but in any case, the derivative of the natural log of e to the x plus x is 1 divided by e to the x plus x times the derivative of e to the x plus x, which in this case is e to the x plus 1. So this works out perfectly. Therefore, we can plug in our values 1 and 0 to get ln of, well, e to the power of 1 plus 1 is e plus 1. And then minus x, well, that's minus 1 in this case. And then minus ln of e to the power of 0 is 1. And then x, well, in this case is 0. So minus ln of 1 minus a minus x, so plus 0. Let's see, this ln of 1 is just 0. This 0 is just 0. So we get an answer of the natural log of e plus 1 minus 1. And we are done.